A single teaspoon of a neutron star would weigh about 1 billion tons on Earth. Neutron stars are the result of massive supergiant stars collapsing after nuclear fuel exhaustion. They are among the densest objects in the universe. Their masses are around 1.4 times that of the Sun, compressed into a sphere with a roughly 10 km radius. A supernova event transforms the core into a tightly packed assembly of neutrons, which gives neutron stars their name. Over millions of years, they cool from initial high temperatures, like 600,000 Kelvin, to become cold remnants. Due to their density, they have strong gravitational and magnetic fields. These stars influence space-time around them, causing phenomena like gravitational lensing. Their magnetic fields emit radio waves and pulsars. These radio waves are detectable on Earth if aligned with our planet as they rotate. The birth of a neutron star sees a dramatic increase in rotational speed due to the conservation of angular momentum. Recorded speeds are up to 716 rotations per second. In binary systems, neutron stars can merge with other stars or black holes, forming kilonovas and emitting short gamma-ray bursts and gravitational waves. There are two types of neutron stars: pulsars and magnetars. Pulsars are common and have radio wave beams, which are useful for spaceflight navigation. Magnetars have stronger magnetic fields, 1,000 times stronger than regular neutron stars, impacting their local atomic environment. Sharks have been on Earth longer than Saturn has had rings. Saturn's rings are only about 100 million years old, meaning they formed long after the first dinosaurs and mammals walked the Earth. NASA's Cassini spacecraft was assigned a mission before its death plunge into Saturn's hydrogen and helium atmosphere. Cassini's mission was to coast between the planet and its rings, and essentially act as a gravity probe. Precise measurements of Cassini's final trajectory have now allowed scientists to make the first accurate estimate of the amount of material in the planet's rings. Each ring was weighed based on the strength of its gravitational pull. These gravity measurements collected point to an unexpectedly young age for Saturn's rings. The rings contain only about 0.4 Mimas masses worth of material. Every 2,000 Mimas masses are equal to one Earth moon, which means that the rings were only between 10 and 100 million years old. In comparison, the formation of the planet itself occurred 4.5 billion years ago. The researchers concluded that before that, Saturn presumably did not have any rings. A dramatic event must have occurred at Saturn in our recent solar system history. 100 million years ago, the dinosaurs still roamed on Earth. They disappeared when a giant impact occurred near the Yucatan Peninsula 65 million years ago. Now we have evidence that a drastic event occurred near the Saturnian system that produced icy rubble that makes up the rings today. This suggests that our solar system is not such a stable and happy place. Big tech companies and startups are exploring the possibilities of manufacturing goods in space. NASA has provided a $2 million grant to scientists investigating the production of stem cell and gene therapies in zero-gravity conditions. Defense companies are aiming to produce semiconductors in space. Certain conditions in space, such as the lack of gravity, low temperatures, and near-perfect vacuum, enable better quality production of certain ingredients like crystals. Pharmaceutical companies are also interested in space manufacturing for the production of drugs, with studies showing that crystals grown in zero gravity are smaller and more uniform. NASA has been collaborating with commercial partners since 2016 to develop an in-space economy. The decommissioning of the International Space Station in 2031 will open up more opportunities for off-planet production. More privately owned shuttles are expected to increase the demand for in-orbit manufacturing, and the cost and feasibility of accessing space are expected to decrease as commercial space stations become more prevalent. Despite an initial setback when a startup's capsule was denied re-entry to Earth due to regulatory non-compliance, companies are optimistic about the future of manufacturing in space.